Hi friends, in this video we are solving a problem on method of variation of parameters. Given problem is solve the differential equation d square minus 2d plus 2 times of y is equal to e to the power of x into tan x by the method of variation of parameters. Friends, you see they are given in the operator form. You see, first I am writing the given problem t square minus 2d plus 2 into y is equal to e to the power of x into tan x. Now the coefficient of d square is 1 only. So standard form of second order linear differential equation for the method of variation of parameters. Now you can write this as f of d into y is equal to r of x form, because the standard form we are denoting with d square y by dx square plus p of x into dy by dx plus q of x into y is equal to r of x form. So this is the second order differential equation with the standard form for the method of variation of parameters. D square y by dx square quotient is 1. Here also you have 1. So now you can say this is in the form of f of d into y is equal to r of x, where r of x is equal to e to the power of x into tan x. So what is the general solution for this higher order differential equation? We have y of x is equal to complementary function plus a particular integral. Generally complementary function for a general method, shortcut method, and this variation of parameter as it is, but the particular integral case will be dependent on the complementary function. So in the step 1 I am finding the complementary function. To find the complementary function we have to take r of x is equal to 0. So let y is equal to e power mx be a solution of f of d into y is equal to 0. Here r of x is we are taken as 0. Then we will have auxiliary equation f of m is equal to 0. Auxiliary equation f of m is equal to 0. That is m square minus 2m plus 2 is equal to 0. Now we have to find out the roots for this. So how to find the roots? Here you have 2 only. So better to go for minus b plus or minus under root of b square minus 4ac by 2a. So m is equal to minus b means 2 plus or minus under root of b square minus 4ac by 2a. So 4 into a into c, 8 by 2 into 1. So this is 2 plus or minus, this is minus 4, I can write 2 root 2 minus 1 by 2. So 1 plus or minus root of minus 1 I can write I. So the roots of m are here complex. Whenever the roots are a plus or minus bi form, then we will let the complementary function is e power ax into c1 cos bx plus c2 sin bx. What is the a here? A is a real part, and what is b? Imaginary part. Imaginary part is nothing but I quotient, that is here b is equal to 1. Substitute a b values in the complementary function, then you will have e to the power of 1 into x into c1 cos x plus c2 1 into x means c1 sin x. So now you compare this complementary function. Okay, this is the complementary function where c1 and c2 are arbitrary constant. Now in the step 2 we are going for the particular integral. Friends, in the variation of parameter method, particular integral will be dependent on the complementary function only. So generally you see this complementary function we have to compare with c1 u of x plus c2 v of x, where u of x is nothing but c1 quotient. What is the c1 quotient? Here you have cosine x, but outside e power x is there. So u is equal to e power x into cos x, and v is also c2 into e power x. So e power x into sin x. Don't forget to write e power x, otherwise this problem will be wrong, right? Now particular integral is here, in this case you have whenever cf is c1 u of x plus c2 v of x, particular integral is a of x into u of x plus b of x into v of x. So do you know u of x? Yes, write down. A of x into u of x means e power x into cos x. B of x means what? B of x is here we have, don't know. B of x is b of x. V of x means e power x into sin x. So friends, in the particular integral we need to find out the a of x and b of x value. How we can find out means we have a formula. Which formulas we have? You see, a of x is equal to, we have minus integral vr dx by w of x, and v of x is equal to integral ur dx by w of x. Okay, where w of x is called Wronskian of u comma v, that is u, determinant of u, v, u dash and u dash and v dash. Okay, now we will find out the w of x. Already you know v of x is this one and r of x is this one. R of x is nothing but in the given problem r of x we have, that is e power x into tan x, and w of x now we have to find out. If you are substituted in a of x, we will get a of x, and if you are substituted here, we will get b of x. This a of x value, b of x value we will put in particular integral. Then the general solution is cf plus pi. So we are doing now Wronskian. Now w of x is equal to determinant of uv, u dash, v dash. So what is the u you have? E power x into cos x. V is equal to e power x into sin x. Now u dash. U dash is nothing but first term into, this is first term if you consider cos x into e power x derivative is e power x. Next second term e power x if you consider, cosine x derivative is what? Minus sin x. That's it. Next first term into second term. First term into e power x into cos x minus sin x into e power x. This is, you see in this case you will have, this is sin x into e power x derivative is e power x plus e power x into sin x derivative is cos x. So this is v dash. Now you simplify this. What I can take common here? E power x is there. Here e power x, e power x, e power x. So I can take e power x is common in the row, first row and second row. So you will have e power to x. Now if you simplify this, cosine x into sin x is nothing but cos x into sin x plus cos x into cos x is cos square x minus, next you see sin x into cos x, sin x into cos x, next minus sin square x. So from this you can write e power 2x into cos x sin x minus cos x sin x getting cancelled. Then you have cos square x minus half minus plus sin square x. So this is 1. So you will have e power 2x which is not equal to 0. Wronskian is e power 2x. Now we have to find out a of x value. So a of x is equal to, we have minus integral vr dx by w of x. So what is the v you have? Minus minus v is equal to, you have e power x into sin x. Next r is equal to e power x into tan x divided by r is equal to e power x into tan x. From the problem, right side of f of d into y. Okay. Now w of x is equal to e power 2x into dx. Friends, you see numerator e power x into e power x. So e power 2x. So numerator and denominator getting cancelled. Right. Next here you have a sin x into tan x. Product of the two functions in the integration. UV rule you cannot apply because both are integral formulas. So sin x you write in sin x. Tan x can you write in sin terms? Yes. So what is the sin x? Tan x you can write sin x by cosine x into dx. But in this case, this is again a u by v rule type. Okay, numerator and denominator is there. But sin x into sin x, sin square x into cos x only. So how you can solve this problem? Numerator, whenever a numerator and denominator is there, then we have to recall the formula integral of f dash of x by f of x into dx is equal to log of f of x. Friends, if the denominator derivative in the numerator, then we will write log of denominator. But cos x is there in the denominator. Cos x derivative is minus sin x. Is there? No. Sin square x is there. So we cannot apply this formula. So you have to go for any other formulas. Means we have to change the numerator in terms of the denominator. So what are the formulas we have? Sin square x is equal to, we have two formulas. First formula 1 minus cos square x, and the second formula 1 minus cos 2x by 2. But in the denominator you have a cos x only. So first formula is better to take. Second formula we have a cos 2x. So cos 2x and cos not getting cancelled. These are getting cancelled. So in this case I can write the numerator as 1 minus cos square x by cos x. Yes or no? So this is, I can divide a minus b by c is nothing but a by b. A by b means 1 by cosine. 1 by cosine is nothing but secant x minus cos square and this cos getting cancelled. Then you will have cos x into dx. Now integral of secant x is, we have log of secant x minus integral of 1 by this is secant x, log of secant x plus we will write tan x. Yes or no? This is the integral of secant x minus Cos x integration just sin x only. So this is sin x. But here you see friends, outside you have a minus sign. So minus, minus, minus. So this is minus. Then this will become sin x minus log of secant x plus tan x. Next we have to find out the b of x. Now we got a of x. Now this is the value of a of x. Now we have to find out b of x. What is the b of x formula? We have b of x is equal to integral ur dx by w of x. So what is the u? U is equal to, I am writing, already we have discussed previously. U is equal to e power x into cos x, and r of x is e power x into tan x by w of x we got e power 2x into dx. Now we have to simplify this, right? Now you see friends, numerator is containing e power x into e power x, so e power 2x. Denominator and numerator getting cancelled. Next you have integral of cos x into tan x dx. But in the integrand, if you are applied, the integrand is containing both the trigonometric functions, so you cannot integrate directly. So what we have to do, we have to convert into any other formula. You see friends, cos x you write down as a cos x. Tan x can you write in terms of cos? Yes. How you can write this is sin by cosine x you can write. So denominator cosine and numerator cosine getting cancelled. Then you will have integral of sin x dx. What is the integral of sin here? Minus cos x. Okay. Now you have which value? B of x. What is the b of x here? You have minus cos x. So a value and b value you substitute in a particular integral. Okay. Then particular integral will be a of x means sin x minus log of secant x plus tan x. Okay. Into you have u of x is e power x into cos x. Right. E power x into cos x plus b of x means minus cos x into e power x into sin x. So friends, you see here you have sin x into e power x cos x. Here you have minus cosine x into e power x into sin x. So these two are getting cancelled. Then you will have minus e power x into cos x into log of secant x plus tan x. This is the particular integral. Hence the general solution is we have y of x is equal to complementary function plus particular integral. That is y of x is equal to c1 e to the power of, e power x I will write outside, c1 cos x plus c2 sin x into e to the power of x minus e power x into cos x into log of secant x plus tan x. So is it clear for everyone? Right. Thank you for watching this video.